Okay, finally, a lot of writing. So when you do get done with that sentence, it's a little bit annoying, I know, to write a sentence in a math class, but when you get done with it, go ahead and turn your paper over, send it towards the middle so I can come get what you have. It's getting hot already. So we'll have to wait. All right, so it looks like, I guess I'll just take that off the top. All right, very nice. You're all set over here. Okay. Wow. Very nice. Thank you. Thank you. Sorry, I'm not rushing you, am I? It looks like you guys are all like, let's get this stuff out of here. Excellent. All right. Oh, that's the extra. Thank you. Thank you very much. Very nice. Good job. Oh, so sorry. Go ahead. No, please. Good job. Thank you, Bella. Something here? Nice. All right, thanks. All right, hopefully we're coming down the home stretch here. Finish up that sentence and perfect. Don't change it. Let's go ahead and just finish that sentence. You got it. I'll come back. Let's get this. Very nice. Yes. All right, good job. I think I got them all. Do I have all the quizzes? One holdout. Thank you. Any others? We got them all. Okay. So let me show you what I have. And then I also realized that I should have made this quiz harder, but I didn't. So Oz's question reminded me that on the exam, I have the habit of making the question a little bit harder, these questions. So I'll show you just so that you know what to expect. And we'll have a practice test before the next test as well. So first one, super easy. You just pick it right out of the bunch here. It's the average. By the way, you could also average these numbers, these 8 numbers together. It kind of bled over to the second line there, or the third line. So you could average those together to get that as well. The confidence interval, too easy. You just copy. So this is some of what on the actual exam you might have to do a little bit more work. I'll show you. And then here's my statement. Once again, hopefully you were able to figure this one out since it's got the blanks there. I am blank confident, 98%, that the mean number of pillows in MVNU dorm rooms is between 2.9 or 2.93, whatever you want, or 2.92 rather, and 11.8. So that look okay? Any issues with that? Okay, let me show you the second one, and then I'll show you how it might be a little bit more difficult on the actual exam. So with this one, once again, you just pull the numbers right from here. It was a little too easy. But the 0.697, that's the proportion from, it's actually even labeled, from the sample. You could have gotten that by dividing these two numbers though, right? 209 divided by 300. And then the confidence interval came right from here. And then here's the thing that I'll be looking for whenever I read your sentence, is I'm looking for this word or this phrase. That what we're measuring is we're measuring the proportion of students who eat lunch regularly. It's not an average. So up here, this was an average, the mean. So here it's a mean. but here it's a proportion. So that's a common mistake, is that you might write mean instead of proportion. This, we're dealing with proportions. But the rest of this, pretty much the same as up above. You're just writing it with about the students who eat lunch. Okay, so what can you expect on an exam? Maybe I should even have this as a quiz on Monday, is something like this. So notice that on this one, so I just erased or got rid of the stuff that, so sometimes I think, well, you guys know what this is about. So you could compute this and yourselves by actually adding up all of those numbers. Sorry, they ended up on a second line there, but dividing by 8, and you'd get 7.3. So you'd have to fill that in yourself. And then these two numbers, that's easy enough because you know that the lower confidence limit is just going to be 7.375 minus 4.45, etc. And you could do that yourself. So that's the worst. So to answer Oz's question earlier, that's the worst in terms of the formulas you might need to know. And you already know how to compute an average, so that's not a big deal. It's just this. And then down below, I might make you do this, where you actually have to compute the p hat. But once again, that's easy. It's a proportion. You can do that. And then doing these, once you have this proportion, you've got the margin of error. So that's the only formulas that I would ever, I'm not going to make you do this or that. So those, no, just those easy ones. Okay, so we do need to move on to the hypothesis tests. So here we go, the hypothesis test basics. And so first off, let me mention why we would care about hypothesis tests. So each time I give you an exam, I give you 2 versions of the exam. And I actually have the data for the last exam. You remember there were 2 versions. I forget what I put at the top, like it was either a plus or a times. I think that's what it was. But so that I could distinguish between the 2, but they were basically the same exam, just subtle differences, so that it may discourage cheating and so forth. So a hypothesis test allows us to say statistically whether or not one of those exams was easier than the other. That's what we want to do. Now, of course, I can actually look. Let me see if I have that. I should have had it at my fingertips, but I actually have the data. I saved it somewhere. Oh, it's going up there. Let me pull this. Here, don't look at that. Just in case there's anything. Yeah, that's other stuff. Let me see. Do I have that here? Baby project grades. That's it. I've got it. Oh, that's not it. Okay, well, somewhere I remember saving the grades. Let me just look one more time. I won't make you sit here though. Yeah, I don't see it for some reason. I know I did this back when you did your test. Is this it? Oh yeah, this is it. Oh yeah. Okay. How can I do this? Let me just delete your names. Hold on a sec. Delete. Here we go. Yay. Okay, so here's the deal, just so you can see. So so these are your test grades. So the ones with the plus at the top, these are your, so there were however many, 11 of you who took one where it had a plus. You remember the plus with the circle? It said test 2, and then it had the symbol. And then there were 13 of you that had the times symbol at the top of yours. So of the plus people, the average score was 89, and of the times, the average score was about 82. So does that mean that the times, that was, that version of the test was harder than the other one? Well, that's what a hypothesis test seeks to do, is it asks the question, we have data, but that data is just this one small sample. And would it be true that everyone would have done worse on the times version of the test than the plus version of the test? So is one of the tests harder than the others? So this is sort of the basis for hypothesis testing. And and by the way, when we do the projects with the babies, it's a full moon today, by the way. As I biked in, I saw the full moon looming in the distance. So today's a full moon, so that means that there's going to be tons of babies, right? Yeah. I did not. Was there one? Okay, very good. So I missed that. But I go to bed at like 8:30 anyway. So- Oh well, what are you even asking that for? I'm not getting up for a lunar eclipse. I've seen them. Now, if it was a solar eclipse, I would get up for that, but I guess I wouldn't have to get up in the middle of the night. But anyway, so full moon, and yeah, lunar eclipses only happen during full moons. Um, so what they say, this is what my mother-in-law says, that they say that there are many more babies born during full moons. So that's where a hypothesis test would come in. We could compare full moons to non-full moons and see, is there statistical evidence to say that there are more babies during full moons? So why is this not switching? Oh, I see why it's not. There, I have to press a different thing. So there's going to be some steps, and we're going to do this for every hypothesis test from here until we finish the class at the end of April. We're going to do the same steps for every hypothesis test. Number one, we're going to write down a claim. What is it that we're testing? So are we testing whether or not babies are born more frequently during full moons than non-full moons? That sort of thing. The opposite of the claim. We have to have two opposing hypotheses. So we're going to have the claim, opposite of the claim. We're going to practice this today. In fact, the homework that's due Monday is largely dealing with these two items and the third item. The third item is to write down what are called the null and alternative hypotheses. So, and I think, every time I do this, I always end up having to change this to H sub A for alternative. I keep forgetting to change it in the PowerPoint, but there it is. I guess I could always just do it right here. But so the alternative hypothesis and the null hypothesis. We'll explain more about that in just a minute. I guess after I change this thing to an A, and then this is going to turn off for just a sec. Let's see. Clear. There, it magically changed to an A. We'll talk about that in a minute. In fact, maybe we should just pause now and see if we can explain this a little bit better. So let's go and take a look at an example. We'll go back to that slide. It's got 7 or 8 steps on it. But this one will explain a little bit about what the null and alternative hypotheses, what this means. So suppose you want to test whether a college student's, what in the world? Whether college students take less than 3 years to complete a 2-year degree. That may seem like a funny thing to ask, but in higher ed, we're always interested in things like 6-year graduation rates. That is, what proportion of students who come in as freshmen end up graduating in 6 or fewer years. So, because things happen. My wife took 4.5 years. I took 4. Well, unless you count my income, I came in with almost a full year, so I just took my time. But so let's say we want to test this. Then I would say this. First of all, I would do the claim. Let's write down the claim. Claim the average number of years college students take to finish a 2-year degree is less than 3. I hate the English language. Well, it's not that I hate the English language. I just hate having to write. And so because I hate having to write, I much prefer writing this in math. So let's write that in math. That claim, the way I would write that in math, notice that what I say here is that the average is less than 3. That's all that really matters. So I could do this. The average is less than 3. That's my claim. So you'll want to identify the claim. It's not entirely clear, to be honest. Here it says, here's the less than 3, so that's why I'm going to do that. But average, use that Greek letter mu to write down average, and then whatever it is that's here, there's my claim. So that's step number 1. Step number 1 we've done for this one. What is the statement that you're testing? What is it? What's the claim? now I want to figure out what the opposite of the claim is. So what is the opposite of being less than 3? I'll bet you can figure this out. In fact, why don't you go ahead and jot down just symbolically what you think the opposite of being less than 3 is. So I'll find a rando to do this for us. Will is going to tell me what he has. What do you have written down? The opposite of my claim. So what's the opposite of mu is less than 3? Let me write that down. Opposite is mu is greater than 3. Is that what you said? Very good, but it's not quite right. There's one minor thing that is not quite right about that, because I want the complete opposite. So if you are not less than 3, you're either greater than 3, but there's one more option. Yeah, what do you think? Could be equal to 3. Yeah, so it's a little tricky there, that if you're not less than, you're either greater than or equal. So let's put in the equals. There it is. So there are my claim and my opposite. So each time you start a hypothesis test, this is the first step every time. Claim, opposite. We're going to be doing this for like 6 weeks. Different types of hypothesis tests, so it's not going to be too boring. Okay, so we've got that. Next, we're going to identify the null hypothesis and alternative hypothesis. So let's do that here. So the null hypothesis, H sub 0 and H sub A. So which one is which? Well, the trick to figuring out which is once you've written down your claim and your opposite, you want to figure out which of these two things has an equals in it. And that's the second one, right? So the second one has an equals in it, and so that's the one that becomes the null hypothesis. Now, this word null hypothesis, it's such a weird phrase, right? Scientists have strange, and mathematicians come up with all kinds of weird phrases. But this null hypothesis, what it refers to, null, it refers to no difference. So if you think of null as being 0 or nil or nada or whatever you want to call it, that's no difference. There's no difference, and being no difference means equals. So the one that has the equals in it is the null, the no difference hypothesis. The alternative hypothesis is the other one, whichever one does not have an equals in it. And so that's what this whole thing is going to look like, at least the first 3 steps. I'm going to blow through the other, however many, 5 steps that I have here, just to show you what's coming. But these 3 steps are, I believe, the main thing that you're going to be dealing with for Monday. So the rest of the hypothesis test, each time, what we're going to do is we're going to ask the question, oh, I guess we'll do this as well. Is your hypothesis left, right, or two-tailed? And so maybe I'll do that right now. So left, right, or two-tailed, what that refers to is this. So you have a like a normal curve. You have the average here, or the proportion. We'll get to proportions as well. So if I were to sketch this thing right here, the alternative hypothesis, so let's sketch the alternative hypothesis. Then you might have like a 3 down here. I mean, I don't know where the 3 belongs on this curve, but wherever it is, because I don't know what the actual average is. So I don't know what the actual average is, so I don't know where this number goes. But wherever it is, I guess probably it would be more appropriate to put X bar in the middle, but it really doesn't matter. The visual is what I want to sort of point out to you, is that being less than 3, mu less than 3, corresponds to that, which is a left-tailed test. So anytime you have less than 3 or less than another number for your alternative hypothesis, this is left-tailed. Excuse me. If I had, on the other hand, something greater than, if it was mu is greater than 5 or something, that would be right-tailed. And if it's not equal to, that's two-tailed. We'll get to that in a minute. But well, now we'll get to that when it comes up in the examples. So so there's that. You know what? Let's do an example. That'll be good. So here's this is like I just stole this from your Newton, so that you can see what kind of questions you have. And it's hard to read, so I'll read it to you. And you could select, but I think you could just write down your answers. So first off, and we're going to go through the whole claim thing, even though this only asks for the hypothesis, we'll do the claim, and then we'll write down the null and alternative hypotheses. So the pharmaceutical company claims, so you want to look for a word like that, claims that, thinks that, proposes, those sorts of words, claims that at least 38% of adults between the ages of 30 and 40 are overweight. A research group does not think that this is accurate and wants to show, so actually you have both of the hypotheses right there, wants to show that less than 38%. So what I would like you to do now before we actually answer this is try to write down the claim, and let's write down the claim by the pharmaceutical company, this claim right here. Write down that claim symbolically. It says that at least 38%, so that's a proportion. So how would I write that? At least 38%. Take a minute, figure out what symbol you're going to use, and then we'll talk about it. And then after you do that, we'll do the opposite. And then we'll figure out the hypotheses, and then we'll pick from the left. We'll do that last. All right, let's see who's got this. Pick some people. Joshua, do you know what symbol you're going to use to represent at least 38%? Very nice. Greater than or equal to. A lot of people forget the equal to part, but this says at least. You see that word, at least, which means 38% or more. Very nice. So this is going to be something like this, or you could write it as 38%. I don't care. Now that we've got that, let's write down the opposite of that. So August, do you know what the opposite of that claim is? Perfect. P is less than. And notice that this is actually the claim made by the research group. Where does it say here? Yeah, less than. There it is. So they actually have it written, both of them, both the claim and the opposite. So however you do it, though, that's not really that important that you label them properly here. What really matters is that we get them labeled properly down here. So let's take those. One of those will become the null hypothesis. Which one is it? So Trinity knows, though. Which of those two is the null hypothesis? The which one? The claim, yeah, the one that has the equals in it, because we know that null means no difference. And so we have this. And then the alternative, of course, is the other one. Very nice. And now we just have to sort out, now that we've done all this, and I encourage you, I know how you're going to be. You're probably not going to write it all out on a piece of paper, but you should when you're doing your homework. And then go to the choices and say, okay, which one matches? And I go over here and I say, hold on a sec. None of them match. Well, here's the deal, is that some statisticians, and Newton is like this, they will take the null hypothesis, and since it's the no difference hypothesis, they drop the greater than part. So whenever you're trying to figure out which of those matches this stuff, start with the alternative. So let's go through and figure out which one works with the alternative. Looks like this one does. And then notice what they've done is that they've just taken that null hypothesis and they've left off the greater than part. That's okay. It's okay. It's just the way that they like to think about it. I kind of like having both, but it's fine. So that's how you're going to do it with Newton. And to be honest, when you're doing exams or quizzes for me, you can do it either way. This is the way I do it just so that I can, it feels easier to me. But if you prefer to do it the way Newton does it, then just do this. However, the claim is still that, because it's written right up there. That's the claim. So mathematically, this is a little bit more correct, but we're not going to be looking at the sort of the formulas that are way, way down below all of the stuff we do. We're going to let Excel deal with those. Okay, so let's sort out. Okay, I'm happy about that one. Let me see, what's this? Let's save that and go back here. One more. How about this one? Give me a sec. I got to clear this. Okay, there it is. Okay, suppose you want to test whether the mean salary of nurses is different. You can tell I wrote this probably 10 years ago. Is different from $45,000. What are the null and alternative hypotheses? So go through the whole process. Claim, opposite of the claim. Ooh, I forgot something. Just a minute. Let's pause. I forgot to talk about left, right, two-tailed. So this particular thing, is this left-tailed, right-tailed, or two-tailed? Here, I'll even put the options down at the bottom: left, right, or two. So this is tails. Let's choose. I'll explain why I care so much about this, but take a minute. You pick. You've got three options. Abby W., do you know which one it is, left, right, or two? You want to give you a little hint? Yeah, so this is one way to tell, is you look at the alternative hypothesis, right? And take a look at this symbol here. See that symbol? It looks like an arrow, doesn't it? Which way is that arrow pointing? Left-tailed, very good. Left-tailed. So that's a little way to figure this out, is if you look at the alternative and you think of that as being a little arrow, is it pointing to the left or is it pointing to the right? Here it's pointing to the left. On the other one that we had, oh, I just erased it, didn't I? The other one was right-tailed because the symbol was, here, let's see, where is my thing? Here we go. This, oh, no, that one was left-tailed as well. Okay, well, we had a couple. If you had something like this, P is greater than 50%. That is right-tailed. Notice that that symbol looks like an arrow pointing that direction, over to the right. So that's one easy way to figure it out. So thanks for being my, helping me out, Trinity, or Abby. Okay, so yeah, we were going to do this one, and then we'll go through the rest of, I guess I've got 20 minutes, so we've got time. If we have time, we have some statistics you can use and some magic tricks. But if we don't get to the magic trick today, we will do it on Monday, don't worry. Oh yeah, so claim. I'll write down what you need. Claim, opposite, H0, HA, and tails. All right, so let's see. All right, Gracie, what is the claim here? So you're going to want to figure out each one of these. Here's a little hint for you. Every one of these is either going to be about a proportion or an average. So that's the first thing to figure out. So is this a proportion or an average? It is an average. We got mean, so I'm going to start with mean. And then we have to figure out, it's going to be some number. It looks like this is the number. And what symbol is going to go between those two? So is different than, how would you represent that? What was that? Not equal to, is that what you said? Okay, that's what I thought. It's hard for me to hear sometimes. You know, I went to too many rock concerts as a child, and now it's the way it is. So sorry about that. Yeah, very nice. So mu is not equal to. English is hard. Don't blame it on the math. Word problems are hard because of the English. It's because there's multiple ways to write the same thing. In math, one way. I love math. By the way, I like to say the reason I went into math is I spent first grade in England because my dad was on sabbatical. He went to Oxford for that. And so I learned English from the English, came back to the States. Everything was different. I got spelling errors and other grammatical errors. I'm like, what is wrong with these Americans? So I just gave up. What's that? Yeah, whatever. Anyway, yeah, it was more the spelling that really got to me, like tire. Come on, put a Y in there. Yeah. So yeah, I have papers from second grade where I've got all sorts of like red marks. Like, come on, people. Anyway, so yeah, it's English is the problem, not math. Math is consistent. It's beautiful. Okay, let's get the, sorry, I got off my soapbox there. Kirsten, what is the opposite of this thing here? Yeah, it's equal to. Very nice. Good job. Equal 45,000. There we go. Next, we need another volunteer, and this is going to be for the null hypothesis. So take a minute. You can figure this out. Which of these is the null hypothesis? So Alec, do you know which one it is? So you want the one that has the equals in it. The opposite of the claim. Very good. Yes. So, well, this one is tricky though. So I gave Alec the hard one. This one's tricky because they both, technically, they both have the equal symbol, don't they? They both do. But which one actually means that they're the same? And that's the opposite of the claim. The mu is equal to, so equal to 45,000. So, so one way you can think of this is that the null hypothesis is always equal, and this is not equal, not the null. Okay, so now that we got that, we have the alternative is that mu is not equal to 45,000. And now you have to think in terms of, here we go, here's this, there's x bar is going to go in the middle when we finally do this. So when I represent this, not equal to, yeah, is that going to be, like, what direction am I talking about? Yeah, what do you think? Yeah, both directions. So yeah, this now I'm getting confused by the way that this is written, but yeah, this is going to be, so you're going to have, yeah, I know. Well, it's because when we get to it, you'll see it. We'll put a mark on both sides. It'll make more sense. It doesn't make a lot of sense now. Sorry, but not equal to means both directions, right? Both directions. So the tails, it's a two-tailed test. Two tails, and it's hard to read nonetheless. So two-tailed, tailed, beautiful. Okay, 832. Okay, so let's go through the rest of this list, and then we'll get on and we'll see if we have time for some of the other fun stuff. If not, don't worry, the fun stuff will be on Monday. So this is every single hypothesis test. You'll do these first three things. Then the next thing you're going to do is you're going to figure out what alpha is. So this is a little tricky to understand what alpha means. Alpha is kind of like, and let's see, do I have this here? I don't have a diagram for alpha. Oh, I do have it. Alpha. Okay, just trying to decide if I want to deal with this now or on Monday. Let's come back to it if we have time. So alpha tells you sort of the cutoff. How much of a, no, we'll do it now. Make more sense. It'll make more sense, alpha. Okay, so alpha will make more sense if we do it now. Okay, so possible outcomes of a hypothesis test. Let's see. So let's talk about a hypothesis test that you might be doing. Let's say you're inspecting your parachute, getting ready to jump out of an airplane. You have different things that could happen. Number one is that the parachute might fail. That's going to be my null hypothesis. The parachute will fail. And then the alternative hypothesis is that the parachute will not fail. So you want the alternative hypothesis to be true. This is typical of when you're doing research. Researchers usually want the alternative to be true because that's exciting. It's exciting if the drug is an improvement over what we're usually doing. It's exciting if you can say that this particular thing causes cancer or whatever it is. That's exciting. You can write a paper and get it published. So usually we're rooting for the alternative hypothesis. And certainly if you're going to jump out of this airplane, you want the parachute to not fail. So what could happen? Well, oh, here's the guy. There he goes. Very nice. So what could happen? You could conclude that this language is a little bit funny, but you could conclude that this is not true. So because of the mathematics, we end up using language like this. We're going to reject the null hypothesis. So we don't think this is true. which means the alternative is the one that's true. The null hypothesis is false. And if this is what actually happens, if we do our math and we say, hey, I don't think that that is true, I think this is true, then we would say, I'm going to reject the null hypothesis. I'm going to jump out of the airplane. That is a correct decision. So far, so good? Sure. Let's say that we do the other thing. Let's say that we decide that we don't reject the null hypothesis. That is to say, we inspect the parachute and we conclude from our mathematics that we think that the parachute will fail. And so we decide not to jump. So we think that, that the null hypothesis, this is what we think. This is what is actually true, because one of these is actually true. And that was correct. So those are the correct things that we could do. The things that would be bad is if we make a mistake. But one of those two mistakes is worse than the other. We really don't want to reject the null hypothesis if it's true, right? We don't want to look at this and say, I don't think this parachute will fail, jump out of the plane, and then find out that it does fail. So that we want to avoid at all costs. On the other hand, this, what's the harm in this? Well, the harm is that you're either up in the plane and you're like, I'm not going to jump, even though it turns out the parachute's perfectly fine. Or you're on the ground and you're like, there's a problem with this parachute. I'm going to repack it. And so it takes more time. But, you know, what's the big deal? So that's not that big of a deal. This, though, is a big deal. And so we call these different things. This error is way, way more problematic for us than this one. Now, there are other situations where this error is the one that you want to avoid, and this isn't that big of a deal. In statistics, it's kind of like trying to put a rug in a room that is a little bit too big for the rug. If you push it into one corner, it's going to pop up on the other corner, and then you go over to that corner and you push it in, it'll pop up. So you can minimize one of these, but it'll increase this. So if we avoid this, it'll mean that we are going to end up having to repack our parachute more frequently, even though we didn't have to. But we're not dead. So that's a better option, right? So here's what alpha is. Alpha is the chances of doing this. So literally, alpha is the probability of this happening. So when we start our hypothesis test, at the front end, we're going to decide what is our tolerance for this kind of error. When in doubt, we're going to say 5% error. But I think that we'd all agree that if this were the hypothesis test, that the parachute thing, I would want alpha to be like 1 in a million, maybe, really, really low. The consequences of making this low, though, is that this ends up becoming bigger. You end up making more of this type of error. But if that's, like if it's something that, now, just to relate this to like drug trials, for example, doing this might cause us to have to spend a lot of money, or maybe doing this might cost a lot of lives. I don't know. There's different things that might relate to the two different errors here. So depending on whether you want to release the drug early, despite the fact it might have side effects, depending on the benefits of if it's drug trials or whatever it is that we're studying. So anyway, that's the deal with alpha. So you choose your alpha level, but when in doubt, alpha is 5%. So 5%, so alpha. Then we're going to determine which distribution you use, and this is going to differ. Are you doing a mean, or are you doing a proportion? So it just, when we basically this just affects, wow, that's hard to read. It affects what we do when we go to Excel. So this is going to be, how do we use Excel properly? So that's basically all that is. Then you're going to compute what's called the test statistic and the p-value. The p-value, and we have time. I can illustrate the p-value with this deck of cards. And then make a decision to reject or fail to reject the null hypothesis. And finally, and we'll talk about that next time probably. And then finally summarize the results in a complete sentence. That's going to be annoying, but thankfully for you, sort of like with the complete sentence that I made you write here, I'm going to give you a template. So you'll know how to write your complete sentence. Okay, so let's see. I need a volunteer. Avery is my volunteer. So Avery and your friends are going to do this. We need, let's see, where's Avery? Avery is right here. Oh, here, I'll give it to, here you go. You have this deck of cards. Abby, take that deck and just cut it. Cut it. You know how to cut a deck of cards? Yeah, and complete the cut. That means you put the, yeah, there you go. So now it's somewhere, now Avery, give it to Avery. Avery's got her deck. And so you can cut the deck as well. Wait, did you just mix up my cards? Oh no. Well, this may or may not work. Okay, so you can cut it as well. Do you know what I mean by cutting a deck of cards? Very nice. Now, here's what I'd like Avery to do is, Avery, you're gonna pick a card from the top card, and look at it, don't let me see it. And what's going to happen is Avery is going to tell me, let's see, she's going to tell me what the value of her card is, and I'm going to tell you the suit of her card. That's a 1 in 4 chance, 25%. So if alpha is 5%, that doesn't really impress you. So if we're talking about like a p-value, my p-value for this little experiment is 25% if I get it right. So everyone understands, if I pick this right, 25%, and if my alpha is, where's my alpha? Here it is. If it's 5%, this is not impressive. So what is the value of your card? It's a what? It's an 8. So it's an 8, and I'm going to tell her the suit. But before I do that, take the deck of cards and hand it over to Trinity. And Trinity's going to take the next card, and you look at that card. And what I'm going to do with Avery is she's going to tell me the suit. You know what the suit is? Like clubs, hearts, diamonds, you know that? Okay, so she's going to tell me the suit, and I'm going to tell you the value of her card. That's a 1 in 13 chance. So that's a little bit more impressive, but it's still not 5%. So you should be a little bit more impressed if I can pull that off, but it's still not, it's still within the realm of like, you just got lucky. So what is your suit? It's what? It's a heart? Are you sure? Okay, so finally, Caitlin, yeah, take the next card. Now with Caitlin, don't tell me anything. How many cards are left? There's 50 cards left in that deck. So if I can tell her what her card is, that's a 1 in 50 chance, 2%. Finally, I'm below 5%, and that is something that should impress you. So getting back, I believe that, sorry, Avery, I'm having more trouble with names than I am with the actual suit. Avery has a club, and then Trinity has a king, and then I believe that Kaylin, is that right? Yeah. Kaylin. Okay. I believe that you have 3 of spades. 3 of spades? Is that right? All right. Well, thank you very much. So if you want to know, so here, by the way, so here's the deal, though, is if we were to write down a claim and a null hypothesis, the null hypothesis is that I got lucky. Did I get lucky? I did not. So what is the alternative hypothesis to me getting lucky? I knew the card. Exactly. I cheated. I totally cheated. Yeah. In fact, here, pull the next card. It's a 10 of, sorry, I have to think for a minute, do some math. 10 of, wait, what did you have? You had a spades, or diamonds. Diamonds? 10 of, yeah, you had a 3 of spades. The next one's a 10 of diamonds. Okay, and then the next one, so I've just memorized the whole deck. So that's it. Yeah, so you did, that's why I said got to keep it in order. So yeah, so that was the cheat. Okay, so you should have enough to do your homework. I've got another magic trick we can do on Friday or on Monday to illustrate another aspect of this. But that's it. So thank you for sticking around for this, and we'll see you on Monday.